Alright, so what we're going to do is take a quick look at using Circe for encoding and decoding JSON. As you can see, I've brought in 4 components of Circe into this particular Scala project. So we have Circe core, generic, parser, and literal. Literal is quite nice because it enables you to define a JSON literal in the same way that you could drop a block of XML into Scala, and also supports interpolation, etc. So it's quite nice. Circe version I'm using here at the moment is 0.12.3. I've also brought in Scala test and cat's effect, which I don't actually plan to use. So if we get started and create a new class here, let's go with message. Now let's make this a case class. Don't get that. And give it a companion object with nothing there at the moment. So first things first, of course, let's go and build a test for this. Let's make that a spec. Looks good. Let's add the matches in. Should matches nice. And let's get the boilerplate out of the way. Decode correctly. Okay, so we're going to need a message. And obviously, if you're doing this for real, you'd have a message. I don't, so incoming JSON. Now this is where I'm going to use the Circe literal. Don't want those. So first thing I need to actually import Circe for this. So I need a Circe dot literal dot underscore, and it's happy. So let's say this particular message has a shape that looks like, I don't know, let's have some stuff. Let's actually make it proper JSON. Always forget the quotes. And let's make this an object, and that object can have a. Make that a. Let's have a b. Let's have the bb a 1. Let's go ahead and have an exciting false. And let's go wild and have, let's go with 2020 101 T 0000 Zulu. Let's get date time there. Incidentally, probably not the best way to be passing that data around, and it is human readable, but I think instant's probably a nicer way of doing that. Not to say that's how it is done in the wild, of course. So we've got stuff. Let's have thing. What could thing be? Let's make thing another object. Let's have X and a Y. Again, let's wrap these quotes, make this valid JSON. 50, 100, and let's go with something. What should we have here? Let's go another string. Something else. So does this look all right? It's probably good enough for us to get going with. Practice. So we've got our JSON message that's incoming to us. It could be coming in via an HTTP call, a post request, something like that, or equally it could be the contents of a rabbit message, AMQP, or something else like that, some sort of messaging system. So we have our message, but we don't actually have anything to test yet. So let's pop back over to the message. And let's give ourselves the decoder that we're going to test. So let's make this implicit, because probably when you go and build the rest of the stuff, you can be interfacing with other things that are expecting an implicit value. By putting this in the companion object of this case class, it is in the sequence of places for determining where an implicit can be sourced from. So it's in that hierarchy of places that the compiler looks to go and find or resolve an implicit. So implicit val decoder will be as good as a name as any. Should always type your implicits for sanity. That will save your bacon down the line. Let's go with a decoder of type message. Let's bring that in. Circe equals. Okay, so there's several ways in which you can do this. You can go full potato and go full auto on derivation, in which case Circe will attempt to derive everything. Generally speaking, the teams I've been on, we've determined no use of full auto, because it tends to bite you down the line when you want to make changes to the objects that you're creating these decoders or encoders for. Namely being when we touch on value classes, things like that. You just run into issues where you want to change something, but in actual fact what's happening is the auto derivation at the top level is creating it, and it's never actually then going on to look for your specific override. I mean, it could even be the case that you have a case class and you want to mutate it in some way. You don't want to show all the fields maybe. And again, this causes problems. So again, for sanity, it's sometimes a good idea to restrict yourself to semi-auto. There's also that quite nice macro annotation for Circe stuff, which can be great. But I'm going to show you my old school classic method. So let's derive the decoder for message. Import hi.circe.derive generic dot semi-auto underscore. I was talking all about it, I forgot to actually put the import in. So now we've got semi-auto, we've got the derived decoder that comes from there. And let's go back to the testing. Let's see where we are with this. So now we have decoder there. We can call this decoder and then decode this JSON and pass it the incoming JSON. And then this should be, and what we're going to expect, if everything goes well, the decoder will basically return an either, with a parsing failure being the left and a success being the right. So if it was successful, we should get a right of, and of course this is going to be an instance of our case class. And of course this isn't going to work at all at the moment anyway, but let's give this a run and see where we're at. Okay, so impressive level of nonsense output there. It didn't like parsing that, caused by a parse exception expected and got B. Is this valid JSON? So we open and we close. We have stuff. And we have thing. Stuff opens, stuff closes. We have comma, as we should, and we don't have commas anywhere else in here. So that's not going to work. Give it another go. One useful thing is always drop these into a JSON validator or pipe it into JQ. Okay, so it ran through and it decoded correctly. Which is nonsense, because it hasn't, of course, but this is because we've just said that this will decode into a message with nothing in it, which is all we've set it to do. So in actual fact, that does work. We do get an empty message out, but this doesn't represent this class. Now we could go ahead and write a manual decoder for this that passes through this tree and returns the points. But another easy way of doing it is basically to write your case classes to represent the structure of the JSON elements that you're parsing. So here we have, in the root object, we have two fields, stuff and thing, which also hold objects. So we can have a case class for stuff and a case class for thing. So let's pop back to message, and we're going to need one for stuff, and then another one for thing, and let's put them in there. So we have stuff being stuff, and a thing being thing. And what Circe is going to do, it's going to use the names of the variables here to match the elements in your JSON. If you do have something like snake case, then you can set up a configuration so that it will convert, which saves you having to name things non-idiomatically. So now we've got stuff and thing. What else we've got in that message spec? So we've got stuff has A, B, C, D, and you have the X, Y, and something. Okay, so there is actually another one. I'll dupe that. Okay, and something had something else. This one I'm going to make interesting. Let's make this a value class. I mentioned them earlier. So that held a string with an else. Because this creates an additional issue for decoding this value class. Of course, at the moment, until Dotty comes along, that's the only way of us providing some sort of type safety for a base type. So just string here, because aliasing still enable you to mix and match and swap out with other strings. So stuff, I think, had an A being a string. I think it had a B as an int, C as boolean, and a D as that's its own date time. And thing, we had X and a Y, and then we had a something. I'll probably actually swap those around. So, something, type something. Okay, so we've now replicated the look of that. Stuff, string, int, boolean, date time, and int. Okay, case class. So now, of course, this is moaning at us because we haven't declared what this should be. Haven't populated it. Structure's changed, so we have stuff. And we have thing. Stuff, of course, has A being one, C equals false, and D equals the zone date time of this. Plug that in there. Name things correctly. Thing has X being 50, Y being 100, and something being something else. Okay, so that's what we're expecting to get out. We may not necessarily get that. In fact, we definitely won't, because you can see here, something expects value. And there is no nested value here, so that's not going to work. Let's kick this off, give this a run. Okay, we've got this message. Could not find lazy implicit value of type derived decoder of message. And this is why I think it's very useful to always declare all your bits going down with semi-auto. What this is actually saying here is that it can't find all the components that it needs in order to create this derived decoder. So it's missing some pieces. If we think it's just this one, let's go ahead and create a companion object for this with a decoder. And here we're gonna, this is gonna be a thing. No, it's not. This is gonna be a something. Let's go ahead and add in derived decoder here. Pop back. Rebuild. Same problem, so it's not just that. In actual fact, because we're doing semi-automatic derivation, we are going to have to add in decoders for each of the elements. So in message, we need a decoder for stuff and for thing. So let's go ahead and create companion object for thing. And go ahead and derive it. And for message, sorry, not for message, we already have that one. For so thing, got thing, message, there's stuff. That's the one I'm missing. So now we've got a decoder for stuff, we have a decoder for something, we have a decoder for thing, and we have a decoder for message. Now, the fact that they're implicits means that when we go ahead and try to locate these, it's going to look in the companion objects of the case classes that it's trying to decode, and it will find these particular decoders. So coming back, let's give them another run. Okay, this is improvement. We failed, but we didn't fail because we couldn't find an implicit value anymore. So now we've got a decoding failure, attempting to decode on a failed cursor, and if you look into here, the cursor was thing something value, which we knew was going to be a problem, because for something, which is a value type, we told it to derive it. So this decoder will be looking for value. Of course, value isn't in the JSON we provided, so we're going to have to change this. So we cannot just derive a decoder here. Take it out. Okay, so decoder dot. So the thing we've got in the value class is a string. So let's decode a string. By the way, although we have had to create implicits for all of these case classes we've generated, you don't need to do it for your simple types. So strings, ints, booleans, etc., they all come out the box. Circe already has decoders set up for those. It didn't used to for zone date time, but it obviously does now. So we're going to decode the string, and then of course we're going to map it, because once we've decoded the string from the JSON that's in the something value, we now need to create one of these. So we can take that string and we can simply call the apply method of this case class. So we're decoding the string out the JSON, and then we're passing that string through the apply method of this case class to generate us an instance of something. In fact, if you look at the type in here, this is a string to B, B in this case being something. Pop back over, give this another go. Woohoo! We're now green. So we did actually get everything that we needed to work this now, so we actually have the full path set up. The nice way of doing this and putting all of the decoders in the respective case classes is that if we ever wanted to do any decoding not from the root level, because another way of doing this is to take all of these implicits that are required for doing these types and to put them into the message. So if I'll show you. Let's take these out. So we have a derived decoder for thing, one for course, I have to rename these now. I'm going to put them at the end, actually. That'd be easier. I wouldn't call them this, call them like message decoder or something, but full speed and stuff. So we have all the types then provided that message should need. It's not provided in any of the case classes, and this should still work. So long as I actually change the name of this. And let's give it a run. And as you see, still works. The problem comes if we were to go back and we didn't want to create the JSON of the message, but if we wanted to create the message of, say, thing. Well, thing now doesn't have scope to what it needs. It's never going to look in the message companion object because it's not related to this or in the tree that flows down from this. So you're going to run into problems with decoding. So you're better off putting this all back in here. And in fact, what I would actually say is what I do is I also add the encoders in for the same reason that when you start building these things out, the trees can get quite complex. They can be quite deeply nested. There can be quite a lot of fields in every case class, and trying to retroactively find the one piece that doesn't have the right decoder set or something isn't in scope is a bit of a nightmare. So it just makes your life a little bit easy down the line, especially when you're refactoring stuff, to put things next to where they belong. So let's pop back to our message spec. So we now have the decode correctly, which is fabulous. But we probably could write the other side of this. We could encode correctly. So in this case, this JSON is going to be what we expect. We're not going to decode at all. We're going to encode, but we haven't built that, so we can't write it. So it's going to be encoder, and then you would just apply it. But I'll do that later once we've got the basics in place. So at the message level, I'm going to add the encoder here. Not there. Simply here, and derive the encoder for the message. Let's import that. Okay, so that shouldn't be living outside. Yes, it should. What have I done with my decoder? Oh, I didn't duplicate it. That was silly. Alright, don't break the existing tests. So now we can pop back and we can apply this encoder. This is expecting a message, so we need to go ahead and pull this out. Say val message equals this. So in the encode message, it should be a write. It shouldn't be a write at all. That will literally just give us the JSON. Or not. Could not resolve symbol. Give it the correct name. And let's give this test a run. Watch it fail. Okay, again we've got the same problem. Could not find a lazy implicit value of type So basically it couldn't find a derived encoder. Cannot get the encoder at all. We've seen the same problem. That's because we've only declared it here. We would need to do that in each of the down classes. So what I'm actually going to do is copy this one. There's less changes. Paste it in there. Paste it in there. Paste it in there. This one's a special case. So this is stuff. Change those. These ones are something. Change those. This one is. So I've got message things, something, encoder. Okay, so again, I haven't changed this, so we shouldn't pass still. And of course we didn't. Why didn't we pass? Well, it's because this didn't equal this. What happened here? The JSON that we generated matched the case class because we derived the encoder for this, and it has placed an object holding that value inside of here. That's not what we want, so we can go and fix that. Very similar in the pattern for what we've done for the decoder. So we're going to have take an encoder of encoding string, but because we're encoding after we've gone and grabbed the value you want, rather than in the case of decoding, you do the decoding first, we're going to contra map, which literally switches them around. So in this case, whatever we provide here, which is a beta string, will be done before we apply the string encoder. The B in this case is the summing, so how do we get the string out? Well, we simply access the value method of that. And this pattern you'll use again and again if you're using this case classes. It's exactly basically how you're generating these things. For decoding, just apply the method. You're basically telling it how you go from a string value to a summing, and again in the encoder you're saying how do you get from this to a value that you output, and that's exactly what we're doing here. Pop back over and let's build that. And we passed. Could even run the whole lot. Okay, if we wanted to. Excitement. Let's make sure all of our tests are passing. They are. And that's it.